Hi everybody, welcome back once again to this channel. Thank you very much for joining me once again. We are still continuing with your trial exam paper from Gauteng Province 2023, and we're gonna be looking at this finance question. Quite very interesting. So if you're new to the channel, please ensure that you have subscribed and turn on that notification bell so that you can be notified every time when we upload a new session. Okay, without wasting any time, let's get straight to it. All right, so we are given that Shimi invests 4 million rands into an account earning interest of 6% per annum compounded monthly. She withdraws 30,000 rands per month. Her first withdrawal is exactly 1 month after she deposited the 4 million rand. How many withdrawals of 30,000 rands will Shimi be able to make? Okay, so this is the question now. So the confusion with this question oftentimes it's between deciding whether this is a future value annuity or a present value annuity. Okay, so there's that confusion, and oftentimes people will choose future value annuity, and I don't know why, but there's that trickiness of this question, right? Choosing between, am I gonna use future value annuity formula or we have to use present value annuity formula? Okay, let me clarify that confusion. Remember, when we talk about future value annuity, right? So it's very useful to determine how much you'll have in the future, hence the word suggests future value. So we use future value annuity if we want to determine how much we will have in future if we are making equal regular payments or deposits. Okay, so for example, if I want to build a house in future, I want to save money for school in future, I want to save money to buy a car, like that, I'm making this deposit every month, right? So they will open that is a future value annuity, right? How much are you paying at regular fixed interval of times, and such that you are trying to save for something in future, right? So it's very different from present value. Now present value is in two ways, hence the word says present value. So with present value, it's oftentimes how much am I owing? What is the present value? Present, this is the money I'm owing to the bank, 10 million, right? So, and how much should I be paying at equal fixed interval of time in order to pay off that debt? Can you see? So that's the first case of it. Another case is just like this question, right? Is to say how much, for example, after retirement, you'll hear maybe where you work, they say, okay, you have 10 million retirement amount, but you can we won't give you the 10 million once off. We can still just give you every month a certain amount, maybe 20,000 every month, right? So that 10 million, it's a present value, is the money you have at present, but you want to determine how they're saying we can be able to give you 20,000 every month, like that 20,000, like that, right? So it's somehow depleting that money, just as it happens with the loan. As I'm paying every month to cover a loan, I'm sort of like depleting that loan. Okay, so you'd understand that in this problem, this person probably retired from work, and they say, okay, here's 4 million. Then she took the 4 million, put it in the bank, and then she's saying she wants to be able to withdraw 30,000 every month, right? How many withdrawals will she be able to make? So this money is what she have at present. So hence the formula that will automatically use it's the one for what? For present value, because the money, she has it at present, and we are trying to know how many equal withdrawals. I mean, are possible from this existing investment. Okay, so that is it. So obviously we do know that withdrawals, we are trying to solve for n. We'll go to the formula of present value. It says PV is equals to x into 1 minus 1 plus I exponent minus n divided by I. Okay, so obviously we are looking for n. How many withdrawals, okay, are possible? What is the present value? The present value in this case is what? Is this 4 million. Okay, this 4 million. Let me use a yellow color. So we have 4 million at present. How much can be withdrawn every month? 30,000, right? So that will be your withdrawal, which is your x then. 30,000 into 1 minus 1 plus the interest. We are given 6% per annum compounded monthly, so it's 0.06 compounded monthly. We divide that by what? By 12. All right. Then we have our n, which is what we are looking for. How many withdrawals are possible? Divided by interest, 0.06 divided by 12. Okay, so from this step we can go and simplify this. So we can simplify by dividing by 30,000, then cross multiply this. It goes and multiply there, right? So if we divide both sides by 30,000, so 30,000 this side, so it will go away from here, right? Because it's gonna cancel. Then I take this, I multiply there, right? Just to remove this bracket. Okay, so we'll have something like this. Okay, so we now have something like this. Then we can simplify using our calculator. It's 4 million, right? Divided by 30,000 times 0.06 over 12. I'm just going to use my calculator quickly. So this side I'm getting 2 over 3 is equals to 1 minus 1 plus 0.06 over 12 exponent minus n. Okay, so obviously inside there I can also simplify 1 plus 0.06 over 12. It's gonna give me 1.005, so I can replace there with 1.005, right? The rest is just algebra because you're trying to look for n. So I can take this one to this side. This one is positive. When it goes there, it will be negative, right? So it will be 2 over 3 minus 1, right? Say minus 1, it goes from this side. So it's gonna give me there's no space, I'm just gonna write on top. It's gonna be minus 1 over 3 is equals to negative 1.005 exponent minus n. If you divide by negative both sides, you have 1 over 3 1.005 exponent negative n. Okay, how can we solve for n? We can apply our logarithmic rules, right? So to solve for n, if you apply log both sides, you have log of 1 over 3 is equals to the log of 1.005 exponent minus n. Okay, so now you can see if you apply log, anything on the exponent will go down, so it will be the same as the negative n, the log of 1.005. Okay, so now to solve for n, hopefully you can see there, I can divide both sides by negative log 1.005. Okay, so maybe let me write it with a different color, maybe orange here. So n will be let's see, the log of 1 over 3, which is divided by the negative log of 1.005. all right, so we can finally get our answer for n. So n is gonna be 220.27 months, right? Remember, this is in months, so we didn't multiply it, I mean divide it by 12 to convert it to years. So obviously because the withdrawal is per month. Okay, so how many withdrawals of 30,000 will she be able to make? She'll be able to make 220 withdrawals. Okay, so that's the idea, guys. when you get such a question, I know the confusion oftentimes to decide whether to use future value or present value, but in this case, if you are withdrawing, take it like you are paying off a loan. You know, when you are paying off a loan, you are trying to deplete what you are owing. You are trying to deplete your present value. Okay, just like here, you have this 4 million. You are trying to check how many 30,000s can you take out. Okay, you are trying to deplete that 4 million. So is the money you have at present, hence we use what? Present value. I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.